Hello everyone. This lesson we're going to look at some equations. So equations are used in science because they represent the relationship between the different concepts, right? So there is going to be a little bit of math now and then for sure because it's just used to describe those relationships. So there's a relationship that exists between frequency and period and so on. Frequency and the number of vibrations and the period. We'll look at what that is. More of the math to do with it today. And then we'll look at some vibrations in the world around us as well, just for interest. So let's remind ourselves of the main definition for frequency. So frequency, we already looked at previously, was the number of cycles per unit of time. I mentioned like the number of times per week that you go to the store or whatever, right? And so number of cycles is just a number. There's no units for that. A unit of time, of course, we talked about was seconds. Now we talk about delta t in this context because it's a time interval. It's a change in time. So delta is that triangle. Okay? Delta, literally the Greek name for that Greek symbol. Okay? But it's a triangle, but it's used to represent a change in something. So when you hear delta t, it means a time interval going from like time 0 to 10 seconds or whatever you measure. The units for things here, then, if you look at it, is number per time, but it's like nothing per time. So it's just 1 over seconds, right? Whatever the number is, no units over the units. So you put a 1 in place for the no unit part. So per second is what we even say, a certain number of vibrations per second, or in the case of the store, per week. Just your system international units is seconds. And of course, the other name for that is hertz. All right, so we know the frequency for letter or variable was f from before. We have the delta t in there now for the time interval. And so we have frequency equals number per time. That's your equation to do with that one. So if you're starting to gather an equation sheet, which is a good idea for physics, slap that one on there, label it as frequency, put up some definitions to do with it. Yeah. Extra stuff in this page by accident. I'll clean that up while I'm going here. So same with this one actually, but yeah, there we go. So that's filled in. So if we're looking at measuring frequency, there's my buddy Heinrich. Got his name wrong last lesson. Anyways, I made up for it. When we're measuring frequency, I just have a note here from in the past when I've had students do a task where they're asked to measure frequency. Some people in that class at one point said, hey, let's see how many vibrations happen in 10 seconds. And of course, that ended up kind of difficult because it would be like 6 bit cycles. So it was not very accurate. And so instead, of course, you can say, let's time how long it takes specifically for exactly 10 cycles and get a much better estimate. And so we're going to do just that. We're going to measure, how many cycles, actually the way this is worded is kind of backwards even, but we know we're going to pick the number of cycles. So let's just do 5 to make sure we're going to be able to have that amount of time in the video, and we'll see how this goes. So this was what I typed in last time, I think, right? All right, so I'm going to ask you to grab your phones or stopwatch nearby if you have one, or stopwatch if you have one nearby, and time this. So I will do the same on my end. Hopefully you do the same on your end. We're going to time how long it takes for 5 cycles. So I'm just getting my stopwatch ready here. You may as well do the same. And here we go. So I'm ready. Now everybody can just do their own thing. I'll talk through what I do after a bit when I replay it. But I'm going to get a number first, not talking through my process. So, and you should do the same. So here we go.
I'm not sure what the windshield wipers are saying, but they're obviously fighting words. However, right. I can tell what the dog is saying, but I'm not allowed to repeat that on television.
hopefully you're able to find a 5-second interval. Mine, when I was measuring it, kind of cut off, but I was already in the rhythm of it, so I feel like I got a pretty good number. I got 7.59. 7.59 as I got on that one. So let's just go with that. Hopefully you got something similar to that. I am going to go back though, like I said, and mention my process for this. Let's go here. And so I have my stopwatch obviously reset and so on. And so a good idea to what to do is when you say like start for your measuring, some people mistakenly start at like 1 for some reason. It's hard to imagine that happening, but it does happen a lot. So I encourage saying like either start or 0. And then when you're getting back to the same part of the cycle, you say, okay, there's 1, there's 2, right? So if I'm looking at this, I'm just going to turn the volume down here. So if I'm looking at this, I'm going to say, okay, let's say start. Okay, so there's 1 when I got back, 2 when I got back, 3 when I got back, 4 when I got back, 5 when I got back. And that's exactly the first time where it kind of cut out of me, but I was confident I was following the same rhythm. So I wasn't too worried about it. You could do it again though with only 4 cycles and time that, right? So that time I got 7.65 and the previous I got 7.59, and you might have gotten something similar to that. If we were compiling all the numbers, of course, we could average those and be even more confident of our numbers. So the 7.59 we'll use since I got a very similar number the second time around. And so let's just do a quick calculation of what the frequency is. So we're going to determine the frequency. This is the new part on this. Right? So I could add that in here, determining the frequency. Oh boy. All right, so usual kind of framing of a solution. You look at your GRASP method if you've seen it. So you analyze what you're given, what you're required, analyzing the situation. That's pretty much picking out a formula, working with a formula, and then concluding an answer. I'd like to see the given. The rest I don't really need to see as much. I'll show you what I mean, okay? But you're going through the steps as you go through it. But if you just at least start out with what you're given, because one of the biggest mistakes people make is in physics is just not getting the numbers for the associated concepts into the right spot for that concept in the equation. And so it becomes pretty easy to get it right if you are more specific about it. So for example, you've got the number of cycles is 5. And we've got the time interval, delta t, is the 7.59 seconds. And we're asked for the frequency. So for me, that's really the R, but I'm not requiring that you put the R in for that, because it's just, if for me in given, I always just list what I know and what I'm looking for. Okay, so it's almost given and required really, but we don't need to get too labor intensive with titles and headings and so on. So to me, I look at this very naturally and say, all right, what equation do I have that's to do with this stuff? So that's really my like analyze phase, right? And of course, it's the frequency of, or the equation of the day. Later on a test or a quiz later on, there might be more than one set of equation and concept relationship to work with. And so, it's important to pick the correct one, of course. So at this stage, we're just going to put the numbers in, right? That's the solve part, analyzing and solving part. So we're going to have the number in as the 5 and the 7.59 in, and then really the solving part in this case is just doing that division, right? I don't have my calculator link ready to go for my online class like I did last time. Let's see if this one's good or not. Yeah, that'll work. So 5 divided by the 7.59 gives us an answer of 0.658. So I'm just going to do this for now, just to sort of point out what we had as an answer, right? That's what the calculator spit out. I'll just put that in, like, I don't know, whatever. It's getting ugly looking, but that's the answer the calculator spit out. And later on in the course, we're going to talk about significant digits, which means really how many numbers we should keep, so that we're not keeping ridiculous amounts of numbers that don't mean anything, right? So basically about what numbers you can trust. And it's pretty simple if you look at it in this case. This is just 5. There's really no uncertainty in the 5 number, this one here. Whereas here, we approximated 7.59, right? So really the 7 and the 5, or the 7 and the 6, those are pretty trustable for sure. This one becomes way more of an estimate. So, I might say that we have 2 numbers that we can trust, right? In which case you're going to be rounding to the 2, like to 2 numbers, okay? Or if you're keeping all of these, like, I might round that one to 7.6 even, right? Because that's what I can trust, in which case I'm keeping 2. Technically, if I have it written as 7.59, then I really should keep 3. You'll see that later on, though. So it depends on what you write down and what you decide you're going to keep. I will keep the 3, so it goes with what we're going to say. But it might have been a better choice to write 7.6 approximately, because then I was way more in the ballpark for each of the 2 measurements I did, and maybe matching the measurements you did as well. More likely to match, right? The chance of someone having a 9 on the end is pretty small, 1 out of 10, if you will. So 0.6587, so that would be 0.659. And then the units are hertz, which it's not a bad idea to point out that that's per second, just as a reminder to yourself. And so then that's done. And then paraphrase is just therefore the frequency. Right? The frequency is, or was, or whatever, 0.659 hertz. And that's your paraphrase. But the P and the A and the S here, when we solved and so on, these aren't letters I'm requiring by any means. I really do want to see this though. The given, make it look like this, right? And have your given and your numbers listed and what you're looking for listed. And that's the proper way to work through questions. And it's that way because it helps make it less likely to have mistakes. Okay, so it's just not stubbornness or pickiness. It's to help you be successful. All right. So let's move on here. Another version of things is when you have to do more of a solve situation. So notice here, we're given the vibration has a frequency. Not a bad idea to do this kind of thing, by the way, right? You're like, okay, that's a frequency, so I know that. And then it goes for 2 seconds. Oh, that's a time interval, right? So that's a delta t. This is just sort of analyzing, like looking at what we're given, right? And then how many cycles. That's when you're like, oh, I'm asking the number, right? So number of cycles. So when you're looking at your given information, I'll use the green here. Your given is, okay, I got the frequency of 60 hertz. And I've got, it happened for 2 seconds. And we're asking the number of cycles, right? And so I'm recommending at this point, you say, okay, well, that's obviously the given part. Here it's like, okay, well, do I have an equation that's to do with these concepts? Of course we do. It's the one we're talking about today, right? Frequency equals number over time. And we plug numbers into that. And in this case, more of a solve situation, right? But we'll plug in the frequency as 60, because that's what it is. The number is the number as stays as a number sign, and the time interval delta t goes in as a 2. Okay, so carefully put them where they're supposed to be. I don't know if you noticed or not in my soundtrack here, but I almost put the 2 on the top. But I was careful. I double checked. I looked and I saw the time was the 2, so I had to go on the bottom. Okay, we have that, and I really want you to make sure to use math processes for this. So I look at this as we have a divide by 2. We really want to get the number of cycles all alone. So we'll have like the answer, right? So the number of cycles, we want to get that all by itself. Well, we can do that easily by undoing this divide of 2, right? So if we multiply by 2 on both sides, just like in math class, right? Multiply by 2 on both sides. The 2's cancel out, really become a 1. So there's one number, right? 1 times number is there on the right side. And we end up with the 2 times the 60, which is 120. And so we're like saying, okay, well, then that's 120 cycles that it goes through in that amount of time. Okay. So therefore, it goes through through 120 cycles in 2 seconds or whatever. right? So that's really what should happen as you go through this. You might have seen the silly triangle stuff. There's a lot of 3 variable equations, and so some teachers like to try to help students get answers even though they might not have the math skills. I'm personally very opposed to these because they limit, they encourage not having math skills, and of course math skills are going to be needed for any equation. Well, really need anyways, but certainly not all equations only have 3 variables, right? So no one ever does an octagon version of these for an 8 variable equation. So don't rely on that type of thing. You really should develop those math skills and be able to be successful moving forward. I've had university students come back and say, complain about having only really done the triangle, and then university they're stuck. They can't really proceed. So I highly recommend, using the processes, the skills that we have. So I worked through that one with you. This is just the last time I worked through it. Just a file that I'm using for this lesson. And so that's obviously frequency and so on that we did. Period, show you here, okay? So period is the amount of time it takes for one vibration. We talked about that previously. And so if you had, if you're trying to think of the formula and you said, okay, if we had, 2 vibrations and it took 6 seconds for that to happen, obviously they're 3 seconds each. Like it's more sort of an obvious thing, right? 2 of them, it was like if say you spent $6 total for 2 items, obviously they're $3 each, right? So what's working out is this logic of the 6 divided by 2 helps us figure out that the period equation is the total time divided by the number, right? So total time divided by the number of cycles just is logical. So total time divided by the number of cycles, again, I think is very logical. So that's the formula for it. And so if you're working with that formula, you would do the same kind of thing, right? You would list, your given information. I'm just going to streamline this a little bit and see how this goes. But you're given the period, so it's listed first. You're given the time interval, and you're asked like how many cycles was it. Analyze, list what you have, pick out the formula, plug in numbers, and solve it out. Okay. So this one here, I might just do this. I might do this. And we'll just talk about this a little bit because this is the harder solving case. And so I want to make sure to show it well. I guess I probably should have just gone from scratch, but I don't want to make the video too long. But this is when you have your variable in the bottom. Okay. So when you have the variable in the bottom that you're looking for, I'll go this way actually. So the unknown is in the bottom. That's sort of the trickiest solving case, right? So that's the trickier solving case. And again, we don't need a triangle. We're just going to work through this mathematically, right? And so you'll see what I did here is I said, okay, well, that's a divide by the thing we're looking for. That's not great, right? So we're going to multiply both sides by that thing to get it out of the bottom. That's a good first step. And then we're going to have this line here where we have, the new result, right? The 2.3 and the number sign multiply together and the 5 left over on the other side. So then all we have to do to get the number sign all by itself is get rid of that multiply. We have to make sure to recognize that in here, there's a multiplication. What do we do to undo multiplication? We divide, right? It's pretty common for students to say, like if I say how to get rid of the 2.3, sometimes students will by accident say subtract 2.3, right? Get rid of it. But of course, then I remind them like, well, what's it doing though in here? And as soon as they realize it's multiplication, they switch their answer to divide to get rid of it. Right? That's the skill set we need to have. So yeah, we divide that out. I think this thing can go away now. Just wanted to carry you through it. But yeah, so this gives an answer of, again, 0.2.1739 ... That's a nice way to do this, by the way, on your work. Just show the calculator had a bunch of numbers, and then, you're making a choice to round it reasonably. All we're doing for now is rounding reasonably. If you give answers on a quiz or a test, even before we've done the significant digit stuff, where you've kept 17 decimal places, like a ridiculous number of decimal places, I am going to probably take off a little bit of margin for that because it's just like you can't possibly think you trust all those numbers, right? You shouldn't, based on the conversation we've And so, in this case, we have a couple decimal place, a couple numbers to work with, 2.3, 5.0. So I rounded to two decimal places, three numbers overall. Arguably, I maybe should have rounded to 2.2 based on numbers we had, right? Because we only had 2 here and 2 here. So to have more accuracy or more precision in the end than you started with is a little weird, right? So that would round this up to 2.2. Okay, 2.2 cycles, two and a bit cycles basically would happen in that amount of time. Okay, so the units is none. There's no units for that. It's sort of written in as 1, but that doesn't mean anything, right? So there's better to say there aren't any units. Moving on, we're going to notice something here. We're going to notice that the frequency equation and the period equation are inverses. They're not inverses. That's the wrong word mathematically, but it's used interchangeably in language. They are reciprocals of one another. They're upside down versions of one another, right? And so that there was a previous homework question, number 5, that tried to lead you to notice that idea. Okay. Yeah. So if you're looking at converting directly between frequency and period, you don't have to calculate the number and then be able to calculate, you can just actually invert or reciprocal them, really, right? So if it was a frequency of 3, you'd be like, flip it upside down, and it's going to be a 1/3 kind of thing, right? So that's something useful to notice. What's the next one here? So pendulum, if the pendulum in the previous example went for 10 seconds. Okay, so we're going to have to change this to if the wipers from the previous example went for 10 seconds. So we've got a given information here of delta t, it's 10 seconds. Then we're going to use the frequency that we got. Jump up here, get that frequency. Frequency was 0.659 hertz. So frequency from before was 0.659 hertz. From the experiment we did or whatever, right? Some from previous work. And we're asking for the number of cycles, right? So it says all that stuff. Determine the number of cycles that will go through. We could say determine the period to add that. And what's the period? Okay, something like that. So ways we could do this. We could, of course, look at this and say, hey, we've got our frequency equals number over time equation. And so we're going to have our 0.659. Let's move this up a little bit. Ooh, make it easier. My back here. Time interval of 10 seconds, and we're asking how many. And so we're just going to multiply both sides by 10. And so multiplying both sides by 10 is very easy. We just get our 6.59. And that's a number of cycles, right? So it's going to go through about 6.6 or a little over 6.5 cycles, right? Therefore, 6.6 cycles approximately. I'll just put a brief therefore there for that. So that part's done. And so I just want to show here this the idea of the period. So for period, you could do period equals time divided by number. Or we could just go directly to period equals 1 over frequency, since we know the frequency, right? So we could put in the 1 over 0.659, which is clearly the easiest way to go about this, get an answer. Or we could do the time, which was 10 seconds, divide by the number of cycles. And obviously this is going to have a bit more of an estimation if I kept the rounded version. So I'm going to go with that. All right. And if you did the calculation for each of those, see, we're going to do our 10 divided by our 6.59, giving you 1.517. So that's telling us that the period is 1.517. I better make sure I have that right. So let's say 1.52. going along with the, actually, I'll do my trick of 1.517 dot, 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 just to give an idea of what we had, right? And then we're rounding to that, so that's that many seconds. And then what if I did 1 divided by 0.659, right? Hopefully we're going to get the same thing since we're calculating the same concept, of course, right? So on quizzes and tests and things like that, if I ask for a question to be calculated 2 specific ways, it's always a red flag to me if a student doesn't get the same answer each time and doesn't notice that that's an issue. And I end up having a talk with them about paying attention to what this means, right? This isn't just a math class. This means stuff, right? So in the end, it'd be like, therefore, each cycle of the vibration, each cycle of the vibration takes 1.52 seconds, give or take. So that's the idea of that. And so just some fun stuff on the end here. The piezoelectric crystals. So crystals I'll type in. So just some examples of vibrations you might not have thought of, but you actually have probably used in your life. I'll show you how and why. So this is piezoelectric crystals right here. That little flashing you're seeing. I'll turn the light on in a second so you see what's going on. There we go. Just 2 crystals that are being vibrated, really. The vibrations of that rubbing together, that's a vibration, and it actually produces, there's an engineering application as well. Let's go engineering. I'll play this whole thing or not, but I'll try to play some of it. I'm just finishing up a video lesson, but you're welcome to come in and hang out.
What's neat about the whole sensing business is that it's not one thing, it's lots of things that have to happen to make this work. This is apart from a helicopter. This is called a pitch link or a control rod.
I'd kind of like to get a control arm on my Jeep that looks like that, actually. Anyway, sorry, it's unrelated.
And the purpose of this component is as the helicopter is flying, it's spinning round and round and round, and its job is to change the angle of attack of the rotor up here. The Navy asked us if we could monitor the loads on the pitch link wirelessly because they're spinning round and round. You can't attach wires to the diaphragm. The other problem that the Navy asked us to overcome was to make it so that we don't have to power the device with batteries. How do we do this? The science of it, how does it work? Well, there's a board, we call it the pitch link board. It lives underneath all this protective covering. And attached to the pitch link down here are strain gauges, and those strain gauges are set up to measure the tension and compressive loads that this thing sees. This piece here is a piezo electric material.
Same as those crystals, type of thing as those crystals.
Piezo means stress in Greek. When the link sees cyclic strains, that generates power. In here are lots of little fibers running along the length of this.
And so the vibrations of the pitch control arm get converted into energy. So you saw the crystals producing light. In this case, it's sort of rigged or designed so that it's going to produce electricity, electrical energy, and so that gives the power for the sensor, and it tracks, and then they can download wirelessly probably the amount of strain that this thing has gone through, and so they can replace it proactively.
When we apply tension to this, those fibers have a polarization. That
so we don't need those extra details of how it works, but that's neat, right? That's an engineering application of how it can be used, right? So it's a vibration. What's happening in the atoms is there's electrons that are imbalanced, and so when it's stress and strain, the crystal structure, the electrons move from one spot to the other. That energy, when it goes back, gives off as light or as electricity, depending on the situation. And then. So in a barbecue starter, you pull the trigger and it clicks. That's actually a piezoelectric crystal in there. It gives a little pulse of energy, electrical energy, creates a spark. So you've actually used piezoelectric probably in your life. The vibration can go to a voltage. Up here we saw that already, right? Vibration can go to a voltage instead. So that's actually this too, which is the idea of the next thing is to say, okay, well, what about reversibility of this? That would mean if we put a voltage on a crystal, it'll actually vibrate, right? A ton of things in science are reversible. And so it leads to new inventions sometimes, right? This was discovered that vibrations make the light and then eventually voltage. And then someone said, wait a minute, we can actually put voltage on a crystal. It'll make it vibrate. And that's how so-called crystal movement watches work. So if you have a watch that runs on batteries, and the analog watch, the arms go round and round, they work by the battery putting a voltage on the crystal, which makes a vibration. That vibration is the driver for the rate at which the seconds tick on that watch. And so we'll see that more later in the course because it has to do with resonance. Okay? And I wish this was the way that tire pressures worked. I used to say it was, and I found out otherwise. But tire pressure sensors in cars could work off of these vibrations, right? And not have to run out of batteries. So I have tire pressure sensors from a 2010 van in my newer vehicle because it's the winter rims now, and they don't work anymore because the batteries are dead. But they could have not needed batteries. And if you want to do this, I don't obviously, I've done this in the class before, and then I had a student accuse me of having a chipped tooth maybe, or whatever. It said to me, the tooth had chipped. I was like, oh boy, I'm going to get sued. So I don't do it anymore, but plus it's an online class, so it doesn't apply. But if you ever grab some lifesavers, they have them at restaurants sometime, go into a completely dark room in front of a mirror, let your eyes get dark adapted, crunch, 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 and you'll see flashes of light, which is the same kind of thing. Yeah. So pretty cool. Anyway, so there's your vibration stuff. There's your assignment to do with the lesson, and you know how to submit and so on, I think, at this point. So I think we're good to go. So I will find out how to sign off here, and we'll see you later.